Okay, this frame supports a 200-pound cylinder and a 500 foot-pound couple moment as shown, okay? It wants me to find the force at roller B and on member AC, horizontal pin. Okay, so basically all of these forces it looks like, okay? And what it says at the end here is roller C does not contact member CB, and we'll talk about that in a second as we go through this guy. Okay, so what I think I'll do is I'll start with member AC. Okay, and because it's basically saying, hey, what's going on AC, right? So I'll start with member AC like so. Let's All right. So at A, I've got pin joint AX and AY. Okay. I have 200-pound tension being pulled just like this. Again, I know that's 200 pounds, goes over that pulley like that. Okay. I then have a roller at B, which is what one of the things I'm trying to find. I then have this couple moment of 500. That'll actually be negative as shown like that. Now, what's going on at C? Okay, well, at C, I have, uh, it says here the roller does not contact member CB, which means that that roller there does contact right here, which I'm not going to call C. I'm going to call the reaction at C, okay, to differentiate from the pin that is going on at C, because I also have a pin connection here that'll be CX and CY, which I need to determine what it is. So I've got the pin joint as well as the roller touching this member. Okay, and I've got 1, 2, 3, 4, 5, a whole bunch of unknowns in this guy, and we'll hopefully figure out what all of those are moving forward. Now, moving on to the next member, and what I want to suggest with this next member is I can take the pulley along with it. What do I mean by that? So I've got this member here. You may think do that and do the pin connections at D, but rather than do that, I'm going to go ahead and take the pulley as a part of it. That way those pin connections are internal to this piece of what I've got going on here. So I'm going to have 200 pounds going straight down in tension, 200 going in this direction. So rather than like we did in a previous problem where I found the pin joints, okay, at this point I'll just keep those pin joints internal. I don't need to find them for any reason. Just take the two together. They're an internal force, so I only worry about the external, which are those 200-pound force that I've got going on there. Then I've got same B, but in the opposite direction acting here, and then the same thing going on with member C, but instead of up and to the right, I'm going to go left and down like so. Okay. Now, from this, I can go ahead and sum the forces in the x direction. I'm going to get B minus CX minus 200 equals 0. Sum the forces in the y direction. I'm going to have minus 200 minus CY, that equals 0. Now, recognize I did not put the reaction at C here because, again, as stated above, the roller at C does not contact member CB. So the roller doesn't happen, but the pin joint is still there. So I've got those. And then I'll go ahead, well, because now I know what CY is. CY I actually have drawn incorrectly. Okay, should be in the other direction. So let me go ahead and flip those. Okay. So I'm going to actually have 200 going straight up, and that means I've got 200 going straight down right here. Okay. Now I'm going to go ahead and sum the moments. I sum the moments about C, so that 200, the CX go away. Then I've got a couple of other 200s. One is 1 foot over, and it's creating a negative, so it's going to be negative 1 times 200. And then I've got that'll be 4 feet plus 1, so that's going to be 5 times 200, and that's creating a positive moment. So 5 times 200, okay? And then B is creating a negative moment. It's 4 feet up, creating negative, so it's going to be minus 4B. B equals 0. From that, I learned that B is drawn in the proper direction. It equals 200. So let me go ahead and label that here. So that's going to be 200 here, which means my 200 up here is also in the proper direction, as shown like that. Okay? Now, we know a few things. The other thing I want to find is the pin at C. Okay? And again, I already know the 200. Okay? So from the 200, let me go ahead and I'll sum the moment about, oh, look at, I actually sum the, I guess I have to find A as well as I look at this. So I sum the moments about C, probably because I have three unknowns at, or I have three forces at C. Okay, so I'll sum the moments, and I don't really care about the reaction at C. So uh, we will call that sum the moments about C. I'm going to have the 500. Again, its location doesn't matter. Okay, and then I'm going to have one 200 that's positive, one 200 that's negative. That's going to be 4 times 200. That's the positive one. And then I move up one more foot, and I get minus 5 times 200, like so. Move up one more foot to A, and I get minus 6 AX, and then I've got AY as well. That's also creating a negative. That'll be negative 4 times AY. Okay, so I've got that. I'm going to go ahead and sum the forces in the X direction. Well, I have AX plus 200 minus 200. Okay, and I am now recognizing that I've got this CX, but I think I know what CX is. I'll come back to this in a second. And that's going to equal 0. Actually, let me stop for a second right now, because I know from here, I know CX equals 0. Okay, CX equals 0 because if I plug that 200 for B in there, 200 minus 200 is 0, so CX has to be 0. So this CX doesn't even really exist. So I can go ahead and get rid of that. Okay, and then from that, I learned that AX also equals 0. So I can get rid of this AX, and I can get rid of this AX. From that, I can learn that AY then is negative 175. And I guess that's all I'm really looking for, so I can stop at this point. Okay, of course that AY is in the wrong direction, so maybe I flip it. That should actually be downward, and it should be 175, like so. Okay, so I found all the, I could sum the forces in the Y, find RC if I wanted to, the reaction at C, and I can do that. So again, as with most, break it up into pieces. The main thing I want you to get from this is recognize that I could take the pulley and member BC together to keep those pin forces at D internal to the system, so I don't have to include them and worry about solving them because I don't really care what they are. So you don't have to break it up into individual pieces. You can break it down. You can combine a couple of pieces to make the calculations a little bit easier for yourself.